For the last 10 years, web applications have relied heavily on an architecture known as client-side rendering, or CSR. It operates a lot like buying furniture from IKEA. The server delivers the empty structure of a house and then drops a massive pile of flat-packed boxes on the floor. In a web application, those boxes represent your JavaScript bundle. Before you can actually use anything in the house, the browser has to unpack, read, and assemble all of that JavaScript code on the spot. This graphic shows what a standard CSR index.html file looks like upon delivery. It contains almost nothing. It is a bare skeleton layout with a single tag, the app root placeholder. While the browser is busy parsing and executing the JavaScript to fill that empty space, the user is left staring at a blank white screen. This assembly period creates a painfully slow first contentful paint. Search engine crawlers operate entirely on speed. They hit the page, see that empty placeholder, conclude there is no actual content, and move on. Your SEO metrics plummet as a result. Once the JavaScript finally loads, CSR provides a highly dynamic, smooth experience. But relying entirely on the browser to build the page from scratch heavily penalizes both initial performance and search discoverability. To fix this initial loading penalty, developers turn to server-side rendering, using tools like Angular Universal. By running a single setup command, you shift the heavy rendering logic back to the server. The server rapidly processes the entire application and pre-generates the complete populated HTML file before sending it across the network. Going back to our analogy, a user making a request now opens the door to a fully constructed, beautifully furnished home. The visual load is instantaneous, and search engines can read the content immediately. But underneath that polished surface, a severe structural flaw is waiting to trigger. The server provided the static HTML, but the massive JavaScript bundle still has to load in the background to make the page interactive. If a frustrated user tries to type into a search bar or click a menu during this gap, nothing happens. And when that massive background JavaScript bundle finally finishes loading, a huge steel wrecking ball violently smashes through the room. Early Angular SSR relied on a process known as destructive hydration. The framework would ruthlessly delete the entire server-rendered DOM you were just looking at and completely rebuild it from scratch on the client side. Any text the user managed to type was instantly wiped out, accompanied by a harsh visual flicker across the screen. The server-rendered page solved the initial loading problem, only to introduce a massive interactivity problem. To bridge this gap, Angular 16 introduced, and Angular 17 stabilized, a process called non-destructive hydration. This snippet highlights the specific architectural configuration required to activate it in older versions. You import the Provide Client Hydration function and add it directly to your app module's provider list. This diagram represents the server-generated HTML as a DOM tree. Instead of destroying this structure, Angular acts as an invisible spirit, gently walking through the nodes and reusing the existing HTML. As it walks the tree, it silently attaches the necessary event listeners in the background, weaving the static page into a fully interactive network. The result is an entirely invisible handoff. The end user gets the immediate visual load of a server-rendered page without ever experiencing the jarring, destructive rebuild process. The framework is now evolving this process further with a concept called incremental hydration. This wireframe shows how a page can be broken down into specific islands of interactivity. Instead of forcing the browser to process and hydrate the entire layout at once, developers can isolate heavy components, like a complex data chart or a date picker. These complex elements remain completely dormant to save processing power. When the user explicitly scrolls down and the component enters the viewport, it wakes up and becomes interactive. Starting in Angular 17, this highly optimized hydration pipeline is completely stable. When you create a new project using the CLI, it prompts you to enable this architecture by default. By preserving the initial structure and strategically loading the logic, modern Angular resolves the historical tension in web architecture. You get the instant speed and high search visibility of a server-rendered page, cleanly blended with the smooth interactivity of a client-side application.